tagaan siya just. Okay, sige, let's start. Since I will no longer review the Gen Chem, I'll start with the organic chemistry. Though they are fused in one module sa exam, remember we have 3 areas sa exam. We have the area 1, which is the yung may largest na percentage sa board exam. 20% of your total ninyo na score dun sa boards cap will be coming from area 1, and you really have to prepare for the following subjects. So the first one is Gen Chem, and then we have the Org Chem, the Pharm Chem 1. I hope you can still remember the Pharm Chem 1, katong mga elements na daghan kaayo sa nga tanan, including the compounds, and you have the Pharm Chem 2. So, yan lahat. 4 subjects ang need din nyo i-prepare for the area 1. Okay? Kaya mo na, di ba? Kaya, uy, alangan. And then, the area 2, actually, wala na ako kabalo sa percentage sa mga remaining na mga areas. If I'm not mistaken, area 2 is 17.5%. And dalawang subject lang tayo dito, biochemistry and pharmacognosy. So you have to prepare for this. And most of the time, according to them, ito yung pinaka mahirap sa boards. Pero meron itong a little touch of botany at plant chemistry. Little lang. And then area 3 is, I'm not really sure if tama akong ginasulat ha. Kung magbaliktad-baliktad man ng mga percentage, but anyway, tama na siya ang mga subjects under per area. So area 3 is practice of pharmacy, yes. So this one includes your clean farm na naamo karon clean farm, di ba? So please listen jud anang inyong clean farm, and then you have the hospital farm here. So you go back with your lesson. Mostly kaning area 3 murag halos tanan subjects din kay si Ma'am Mabe inyong teacher. Kasi di ba clean farm si Ma'am Mabe, hospital si Ma'am Mabe gihapon, tapos farmcal belongs here sa area 3 mo. Na sa board exam 2 hours ni siya kasi naa siya'y computation. I-add lang na ko na maisip. Dispensing is also included here. Naka-descend. Because dili ko familiar with the percentage. Kabalo lang ko sa mga... Okay, thank you. Dispensing. Human naman mag-dispensing class, no? Human na? Wala pa. Wala pa? Or naga-dispensing mo karon? Naga-dispensing mo karon si Eureka inyong teacher. Pero wala pa mo nag-meet. Wala pa, no? Oo, si Eureka inyong teacher. Sige. Sige. And then, the module 4, tomorrow pa. Nagsakit ba yun daw to si Eureka? Nag-chat siya sa kuha. Pero siya marag di daw niya kaya mag-klase. Baliktad. Baliktad na yung class. I cannot edit this anymore. This one. Baliktad din silang duha. This one is the 15%. This one is the 17.5%. And then, si module 4, si area 4, ano na siya? Lito na ako siya type. Si area 4 is 15% also. This is the area of pharmacology. So kung nakita ninyo, the heart and soul of pharmacy is pharmacology, but actually gamay lang na siya percentage sa board exam. Pero together with toxin siya. Okay, so namoy toxicology karon, 'di ba? Si Ma'am MJ siguro yung teacher. So please do good with that subject also para tandem sila ni Picol. And then the area 5, which is 17.5% gihapon. This is pharmaceutics. So this includes your DDS, your MANOF, your FEE-PHARM, and then your jurisprudence. So naman may jurisprudence, I think, last time sa summer, no? Nag-juris mo tong summer. Nagibalhin man to siya. And then lastly, area 6. This one is for microbio. So manamog microbio with Ma'am Eroy, right? Microbio, and then QC. QC1 and QC2. And actually kasama si public health. So appeal si public health. Board exam subject na siya. Okay? So mo ni siya tanan ang subjects na kailangan ninyo preparahan for the board exam. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 ka subjects tanan. Okay? Saan yung nag-message sa ko? Ma'am, sure na jud na si ma'am. Oo, yeah. So this is the first time na hindi ako ang mag-PCOL. So last batch sa inyo nag-PCOL. And then karon nga batch kaning mga third year si Ma'am Fleur ang nag-PCOL. Kay gihulam ko nila sa medtech na mag-chemistry sa medtech. So dili na siya kaya sa ako ang time sa pharma. So I have to give up a lot of subjects sa pharma to accommodate the medtech. And since walay mo dawat sa QC, kay maglisod daw sila sa QC, so si Ma'am Eroy nag-decide na ibilin na lang sa ako ang QC and pangitaan na lang og teacher ang PCOL. Okay? So ano siya, first time na ako dili magtudlo PCOL, but that's okay. Wala lang ko kabalo. Pero yung ni Flor, ganahan man daw siya og PCOL. So, favorite subject niya. So, wala problem. I don't know. Yo-yo lang. So, kung man ito tag PCOL class. So, ang third year karon ilang teacher sa PCOL. Okay? Sige. So, yun lang. Orientation lang yun for the board exam. Our board exam kay 2 days na siya. First day is area 1 to 3 and area 4 to 6 on the second day. Ana, condition ninyo inyong mind. Okay, so that's it for the boards. Let's start with organic chemistry, and in your free time, kindly watch the video for the Gen Chem. So I will also send the PPT for the Gen Chem together with the link sa video. So sa organic chemistry, we all know that organic chemistry is a branch of chemistry that deals with carbon. That's it, carbon. Lahat ng carbon-containing compounds under sa organic chem. So carbon can bind with itself, kapwa carbon niya, or it can actually bind covalently with other elements such as hydrogen, oxygen, phosphorus, nitrogen, sulfur, and even the halides. So X there is referring to halides, or that's the halogens, fluorine, chlorine, bromine, iodine, though seldom lang si astatine. But take note, class, that not all carbon-containing compounds are called organic compounds. We have exceptions. We have exceptions to the rule kasi may mga compounds tayo na under sa inorganic chemistry but they do contain carbon. So what are those compounds? Those compounds that contain carbonates, yung like for example, sodium carbonate. Kana, inorg na siya. Or those that contain bicarbonate, like sodium bicarb, inorg pud na siya. And those that contain cyanide or kanang CN, like HCN, hydrocyanic acid. They are all considered inorganic though they contain carbon. But the rest na compound nato with carbon belong to organic chemistry. So I hope that is clear. Okay? Questions so far? Wala, tingog mo ha, basig na ko istorya diri niya. Natog na day mo. Una na magtog pa din ha. Okay, next, let's talk about carbon since this is the highlight of organic chemistry. Wait lang. Ayan. So, take note, this one is the only element that can bind with itself. So, the property is called, let me write sa screen, catenation. If you hear the word catenation, it refers to the ability of carbon to form bond with another carbon. Catenation ang tawag. Okay? Please ano ha, take down notes. And then carbon also contains 4 binding sites for other atoms to attach to it. Because remember, carbon belongs to group 4A in the periodic table. And thus, since it belongs to group 4A, it means na meron siyang 4 valence electrons. Let me write sa screen. So if you have your periodic table there, you can see that carbon is found here. This is group 4A, and thus meron siyang 4 valence electrons. If you are asked what valence electrons are, unsa man na siya, unsa gani ng valence electrons, ay meaning ana? Anyone? Walay? Manawag tabi? Char.
Ma'am,
Yes, Isobel.
sa pagka-remember na ko, ma'am, ang valence electrons, isang electrons nga nasa pinaka outermost na orbital
Okay, very good.
sa isa ka atom.
Yeah, so that is correct. If you are asked what valence electron is, it means na it is the it is the electron or the electrons found in the outermost shell. If you go back sa general chemistry class, example, this is the atom, this one is the nucleus here. So this one is surrounded with orbitals. So sa orbitals, that is where you can possibly see the electrons. So dira sila na-distribute. The last level there is the outermost shell, and kung pila ka buok ang electron dinha sa outermost shell, mao na iyahang valence electron. Okay? So I hope ano na siya, klaro na siya. So how do you know na 4 ang valence electron ni carbon? So you can see there, atomic number is 6. The atomic number class, the atomic number refers to the number of protons. Yan yung nire-represent ni atomic number. But for a neutral element, meaning anang neutral element, walay charge. The number of protons is equal to the number of electrons. So for carbon without charge, it contains 6 protons and also 6 electrons. So syempre si protons class makita ni siya sa nucleus. But ingon ko kagaina, electrons are found in the energy shells outside or surrounding the nucleus, and they are being distributed. And you can see that in the electron configuration. So while if you are going to watch the recorded video for the general chemistry, please give time sa pag-familiarize ulit sa electron configuration. Okay? So sa pagkakaroon, diretsoon ako ni siya, pag moingon kag carbon, the electron configuration is 1s2, 2s2, and 2p2. Ay, sorry. Yeah, tama. 1s2, 2s2, and 2p2. Tama siya. So, 6 na siya tanan. Nansay meaning, ana? 1 there refers to the first energy level. So duha lang ka energy level class C carbon. So sa first energy level daw naa siya duha ka electron. But on the second energy level, take note of this. You have 2s2 and 2p6, which means meron siyang 4 na electrons. So ito yung outermost shell niya, and then meron siyang 4 na electrons, kaya 4 ang kanyang valence electron, meaning yan 4 din ang pwedeng binding site. So if this is carbon, meron siyang 4 na electrons sa outermost shell niya, and this will be available in forming bonds with other atoms or molecules. So ingana siya ang explanation nga nung 4 ang bonds na pwede ma-form ni carbon. So carbon is very unique kasi unlike other elements that can transfer electron to form ionic bonds, carbon does not really transfer but share electrons. Nag-share siya ng electrons with the other elements, and thus ang ma-form niya na bond ay tinatawag na covalent bond. So idugang lang na ko niha, pero actually sa Gen Chem gid ni siya gina-discuss. Pag ionic bonding, do not forget transfer of electrons. Pero pag covalent bonding, sharing of electrons. So ang transfer actually happens between a metal and a non-metal. But the covalent bonding takes place with a non-metal and another non-metal. Shortcut na nato na tanan kay para mas dali siya sa board exam. Okay? Questions? Pangutana mo ha, basig ako ray gilamian og explain din niya waday ta nagkasinabot sa ato ang organic chemistry. Actually, I'm hesitant to teach organic chemistry kay dili gyud nako ni siya forte. Pero as much as possible, I'll try to share kung unsay akong nasabtan sa org chem. Kaysa tanan klaseng chem, ni ako ang pinaka-hate na chem. Hindi ko ganahan ani. So mo ni ako ang gisulat kagaina. Electron configuration of carbon is 1s2, 2s2, 2p6, and thus the outermost shell, which is the second energy shell, contains a total of 4 electrons. So remember the octet rule in your chemistry na subject? Octet rule. But this rule states that for an atom to be stable, it needs to have a total of 8 electrons in the outermost shell. Therefore, si carbon is not stable. It needs 4 more electrons to be stable. So instead of giving up the 4 electrons, carbon will end up sharing the electrons to other elements. So hindi siya naga-donate, wala pud siya naga-receive, so walay transfer nga nahitabo, instead mag-share siya, ang tawag ana covalence. So the bonding is called covalent bonding. Now for organic chemistry, we classify the compounds according to functional groups. Pag sinabing functional groups, they are atoms or group of atoms arranged in a specific manner wherein the arrangement class becomes its identity, and at the same time, yan yung nagdidictate ng physical and chemical properties of the compound. So again, pag nakarinig kayo what functional group is an atom, or most likely it's a group of atom, and then may arrangement sila, specific arrangement sila, tapos yung specific arrangement na yan becomes its identity. So for example, pag sinabing alcohol is ROH. So group of atoms sila pero may specific arrangement. It needs to have this R, which is any functional group, but kailangan merong OH. So itong presence ng OH becomes its identity. And again, it will dictate the properties, both physical and chemical properties of alcohol. Now, before tamo abot kay alcohol, syempre let's start with the most basic functional group, and these are the hydrocarbons. So from the name itself, hydrocarbons, syempre ang meron lang dyan, hydrogen and carbon. Yun lang talaga ang makikita natin sa structure or sa molecular formula nila. Though meron tayong tinatawag na substituted hydrocarbon, but let us separate the discussion about that later. Now let's start with the different classifications of hydrocarbons. The first one is called aliphatic. Pag aliphatic class, automatic single chain na siya. Bisag 100 pa na kabuok na carbon, as long as single chain, diretso-diretso ha, like CH3, CH2, 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 CH3. Kung napakay gusto idugtong din ha, as long as it is a straight chain na carbon and hydrogen only, we call that aliphatic. So no rings involved here. Bisag napa na siya chain. Ay, sorry, napa na siya, what you call that? Na siya branch. So example, this one, tapos may branch ka sa taas. Kana na kay branch din ha. As long as hindi siya nag-form ng ring class, aliphatic gihapon na siya. So whether very straight, as in straight lang yung tanan, or straight chain siya with a branch, aliphatic ang tawag ana. Aliphatic hydrocarbon. So wala kang makikita na ring there. Okay? Now the aliphatic hydrocarbons are further classified into two. We have here the saturated and the unsaturated. So how do we differentiate the two? Pag sinabing saturated, you only have single bonds here. So parehas sa alkane, single bond lang na siya, carbon to carbon, pero single bond. Bakit siya tinawag na saturated? It's because of the presence of larger number of hydrogen. Meaning, anak manggod, saturated siya with hydrogen. So, kung i-compare manggod nato sa kanang naay presence ni double bond or ni triple bond, mababawasan sila ng hydrogen, kaya tinatawag silang unsaturated. So, saturated is single bond, unsaturated has the presence of multiple bonds, double or triple. So, therefore, we have the examples there, alkenes and alkynes. So I hope klaro na siya sa inyo ha. I believe kabalo mo ana, kailangan lang yun nato siya i-review. And then we have there, if mag-form na siya og ring, we have the so-called aromatic. We actually have two types of hydrocarbons na may formation of ring. The first one is aromatic, the other one is called alicyclic or carbocyclic. Pag aromatic, again, may presence tayo ng ring, pero most of the time, it has the presence of benzene ring or derivative ng benzene ring. So automatic benzene is an aromatic hydrocarbon. And other examples, we have the naphthalene and the anthracene. So it is your task now to look for the structure of, kabalo man ko nga kabalo mo sa benzene, ana lang man na. Pero you have to look for the structure of naphthalene and anthracene. Naphthalene is the component of our mothballs used as like insecticide. Diba? Kailaman mo ana. So we have naphthalene that is actually an aromatic hydrocarbon. So task ninyo na mangita og ano ha, structure. Sige. Now, how about the alicyclic or the carbocyclic? They also form a ring. So, may chain sila pero mag-form sila og ring. Oo, tama na siya. Saan yung nag-chat? Si Tin? O, itong bilog na white na mothballs na ginabutang sa cabinet kay para sa ok-ok. Para siya sa ok-ok. And then, nag-undergo siya og sublimation, di ba? sublimation man kasi 'di ba the mothballs na murag Mentos, yes, color white,
Solid
that
to
is
gas.
ansa? Dito, color white siya, solid siya, 'di ba? And then pag ibutang nato siya for example in the cabinet, after some time mawala siya pero you will really know na naay mothballs ni butang didto kay naa siya amoy. So solid to gas, tama siya, tama Sarah. Solid to gas, so nag-undergo siya sublimation. And kindly look at the structure of naphthalene. It is an aromatic hydrocarbon. So derivative na siya ni benzene. Pero class, kung alicyclic or carbocyclic, it will also form chains. Pero ang ilahang manggong properties, ang ilahang behavior is the same with the aliphatic na like mga single bonds. Parehas sila kay alkane. So kung select ko sa screen ha, kadjot lang. If this one is the benzene, ayan, this one is aromatic. Si alicyclic or carbocyclic class, mag-form gihapon siya for example og ring, pero dili siya matawag as aromatic. Ang iyahang properties parehas with the aliphatic hydrocarbon. So we call this benzene. While this one, it is devoid of the double bonds. We call this the cyclohexane. Now, pangutanon tamo kay kanina siya double bonds, pero take note of the other example, cyclopropene and cyclobutene, which means may presence ito sila ni double bond. Ito okay lang, madali na ma-identify na uy, wala siyang double bond, automatic, it is an alicyclic or carbocyclic. So paano ito? May double bond, cyclopropene and cyclobutene. How will you know if it is aromatic or just an alicyclic or carbocyclic na hydrocarbons? Anyone? Naphthalene fused to benzene rings. Oh yeah, very good. Yes, Hessler. Pag naphthalene, duha ka benzene ring na gifuse. Pag anthracene, 3 ka benzene ring na gifuse. Okay? Pero ang uban din ha na wala pa nakasulat, you really have to research for the structure of those examples. Anyone who knows or who can still remember your lessons sa organic chemistry on how to differentiate the aromatic hydrocarbons and the alicyclic or carbocyclic hydrocarbons? Naapay maka-remember or nabaon na tanan sa limot? Okay. Sige, it's through, nabaon na sa limot ang uban. It's through the use of the Hackles rule. So this one is being used to determine if a compound is aromatic or not. And we are going to use this formula. Meaning, gina-compute na to class kung aromatic ba siya or dili. The formula is 4n plus 2 equals pi electron. Again, 4n plus 2 equals pi electron. Now take note, if the n, ang i-compute man gud nato ani class is ang n. So if you get a whole number na n, that means the substance is aromatic. It's a derivative of benzene. But if you get an n na naka-fraction, dili siya whole number o kaya zero siya, it means that the ring there is just alicyclic or carbocyclic. So let us give an example on how to compute this Hackles rule. We have here, example, let's try benzene. Benzene, sa kemogid na siya ang mother nilang tanan na benzene. So benzene has 6 carbons and we have here the double bond. So how do we compute that? So di ba ingon ko ang n atong i-compute, 4n plus 2 equals the pi electron. How will you know the pi electron? These are the electrons class involved in the double bonds. Okay, again, the pi electrons are the electrons involved in the double bonds. So you are just going to count. So you have 1 electron at the end of each bond. You have 2 electrons there. You also have 2 electrons here, and then you have here another 2 electrons. So all in all, benzene class has 6 pi electrons. Again, ang pi electrons are the electrons involved in the double bonds in the compound. And then we will just compute. So this is just simple math. 4n plus 2 is equal to 6. Let's just transpose this. Transpose natin sa kabila. So this becomes 6 minus 2. So 4n equals 4 divided by 4 both sides. So n is equal to 1. So 1 is a whole number. Therefore, benzene is really an aromatic compound. Okay? So I hope klaro na siya. Questions sa Hackles rule? Walay? Sure na gyud? Napabakoy ka istorya diri? Or natulog na? Ang wala nag-react kay natulog na. Wala na nag-react. Kinsa wala nag-react din he. Okay, sige, nag-react man. Sige, let me give you another example for the Hackles rule. For example, you have here a cyclobutene. Ano lang, 1 cyclobutene. Butene. But is apat ka carbon, di ba? So 1, 2, 3, 4. And on carbon number 1, you have a double bond. So nakay double bond din ha. This one is a ring. So ang ring class, not necessarily dapat unom jud no, hexagon dili. Basta mo form na siya og ring, diha ka mag-decide whether aromatic siya or not. So kani ato siyang i-compute. 1 cyclobutene na siya ha, or cyclobutene to be in simpler terms. So we have 4n plus 2 equals pi electron. Again, the pi electrons are the electrons involved in the double bond. So you have 1 electron at this end, and then at the other end you have another electron. So for cyclobutene, you have a total of 2 pi electrons. So 4n equals 2 minus 2 equals 4n equals 0. Divide both sides with 4. Therefore, n is equal to 0. So take note, whole number has 0 is not included there. So this one is not aromatic. So kanina si benzene, the answer is 1, aromatic siya. Ito, the answer is 0 for cyclobutene. This is no longer aromatic. So ang atoang classification for it is alicyclic, or we call it carbocyclic. Okay? Sige. Wala pangutana? Anyway, you can just unmute anytime if you have questions, or you can send your questions sa chat. As usual. Sige. I hope kasi nabot na ito ha. Kailangan dito siya mapasabot kay para sa boards. Malay natin kung daghan or organic chemistry sa board exam. How do they make the questions? The members of the Board of Pharmacy actually makes a lot of questions, and then nilalagay lang nila yan sa sa computer, ang questions na as in daghan kaayo. And then actually during the board exam, the Board of Pharmacy also don't know unsa na mga questions ang migawas, kay ang computer ang mamilian na. So sa kadaghan nila gi-input sa computer, ang computer ang mamili, and then i-print na lang siya sa PRC. So again, the BOP, the Board of Pharmacy members and the chairman, kabalo sila kay sila may nagbuhat sa mga questions, pero kung kanang specific questions gyud nga na-include dito sa 100 items na per area, wala na sila kabalo. Okay? So random na siya. So wala ta kabalo whether mas daghan ang gipili ni computer nga OrgChem or GenChem or PharmChem 2 or PharmChem 1. Okay? Sige, let's talk about the hydrocarbon derivatives. So hydrocarbon derivative siya, meaning we still have the carbon and the hydrogen, but some of the hydrogens are being substituted with other elements. So these other elements can be oxygen, nitrogen, sulfur, or halogens. So mga fluorine, chlorine, bromine, or iodine. As long as they substitute one or more electrons, one or more hydrogen, magiging hydrocarbon na siya. So we have halogen-containing hydrocarbons. We call them alkyl halides if Rx lang siya. Rx means you have here a straight chain hydrocarbon. Meron kang aliphatic hydrocarbon, and in the structure na ay nasagol, na ay naka-substitute na any halogen, whether fluorine man na or bromine or iodine, as long as kani ang ilahang arrangement, aliphatic hydrocarbon plus the halides, we call that alkyl halides. Pero if it is a combination of the aromatic ring and then there is the presence of the halogen, we call that aryl halides. So mana siya ang pangalan sa functional group. And then we also have hydrocarbons na ang substituted element is oxygen. So actually daghan ni sila. We have the alcohol, we have the phenol. Alcohol is ROH. The phenol is actually a benzene ring with an OH. And then we have the ether. I'll just write the general formula on the screen for your reference of the different oxygen-containing hydrocarbons. And then aldehyde is RCHO. R, by the way, ulito nako, is any functional group. So it can be an alkene, alkyne, alkane. It can even be alcohol as long as any functional group siya mo na siyang R. So any functional group basta as long as oxygen is found at the center. Okay, and then RCHO is aldehyde. This one is ketone. Sorry, this is RCOR. That's ketone. And then carboxylic acids also, you have RCOOH. Okay, RCOOH, carboxylic acids, and actually we have derivatives of the carboxylic acids. When you say derivatives, this hydrogen here is being substituted by other elements also. So just like esters, RCOO, instead of H, you will have another functional group. Now for amides, you have here RCONH2. So the substituted elements, we have here the oxygen and the hydrogen. And then we have the anhydrides. I will have a separate discussion of these anhydrides and the acid and acyl chloride. So medyo complicated na silang tatlo. Separate ko na lang siya. Let's concentrate first sa mga very common na mga hydrocarbons. Pa-distract sa akong cellphone, daghan kay mo sulod nga messages. So pasaylo ako ninyo kung dugay ko mutubag. Kay puno as in very puno ako ang inbox karon. Lahi pa ang gikan sa eskwelahan nga message, either kay dean, sa mga head, sa lahi ng mga teachers, lahi pa ang gikan sa estudyante, lahi pa ang sa akong pagpamaligya. Lahi pa sa akong pagpamaligya, lahi pa ang sa mga unsa-unsang mga butang. Ano ko kasabot? Ug unsay nahitabo. Okay. Sige, let's move on. We have the nitrogen containing, right on the screen. This one is RNH2. So please take note the difference between amines and amides. I really don't know how to pronounce this. Others would call this amines. Others will pronounce this as amines. But I'm used to amines manggod with this one. So RNH2. So this is any functional group, and then directly combined with the nitrogen. Sa daw sana all dili. Dili gyud mingaw gang akong messenger. Grabe jud ang message. Nagsige na lang kung pangay pasaylo sa mga nabaon na sa limot. Charot, nabaon na dito sa pinaka last. And then this one is amines, diba? Ang kalahian nila, you have here at the center are carbon double bond oxygen before ka magkaroon ng NH2. So, I hope dili mo malibog, ana. And then we have heterocyclic nitrogen compounds. So, these are compounds with a lot of rings, pero you will see the presence of nitrogen. So, heterocyclic nitrogen compounds. You ask questions. And then we also have sulfur containing the thiols, the thioethers, and the thiophenols. As long as you can see the sulfur in the structure, pag makabati gani mo og pangalan na thiol, automatic sulfur na siya ha. It has the presence of the sulfur. So like see thiols, you have here the RSH. So you have R, any functional group, the sulfur and the hydrogen. And then this one is a combination of sulfur and then your ether. And this one also combination of your sulfur and you have the phenol. Okay? Sige. So introduction lang na siya. Introduction lang yung lahat ng ating functional groups. Questions before we'll move on to another topic? We are, we have 20 minutes na break. How do you want our break? Isahon ang 20 minutes or kaduha ta mag-break nga 10 minutes, 10 minutes? What do you think? Mag-call ta ba? Char lang, hindi ko pala mag-call. Tingog na lang mo. Ano sa inyo ang gusto? 20 minutes na straight na break or 10 minutes ta? Kaduha ta mag-break? Dili mo ka-decide. Dili mo ka-decide. Kadjat, di ko kami maghimog poll. Walang poll. Poll, create. Wait. Basig magdiritso-diritso ko ba mabtan tag alas 6 wala pa ko ni hunong, walay ihiay, walay kaunay. Single choice. Tapos saan ba yun siya? Makita ninyo ang poll dili. Dara. Launch. Sige daw, ang madaog mo na itong tumanon sa atong klase, ha? Mag-break na lang mag inyo, ha? Sana all. Sana na eh. Okay. So, 10 minutes. 10 minutes per hour. Ano sa oras nagsugod itong klase? Alas 3, no? Alas 3. So, pagka 4 o'clock, mag-break ta. Okay, mag-break na ta. Kaya 4 o'clock na. Sige. Ano na lang, like alas 3 magsugod, no? Pag 4 o'clock, mag-break ta. Tapos balik mo og 4:10. Okay. So, let's continue with another topic for organic chemistry. We have here ways of representing the structure of molecules and classes of formulae. So, we have different formula na ginagamit in representing our different organic compounds. So, we have here the empirical formula. If you hear this word, or words, you have empirical formula means the simplest possible formula for a given compound. So since this one is the simplest formula, it will actually not show you the exact number of atoms present in the compound. So i-simplify kasi siya. So parehas sa ato ang math, di ba nag-simplify ta sa math, no? Kung pwede pa nato siya ma-reduce in lowest term, like mga fraction nato, ginahimo nato siya sa math. Sa org-chem, pwede po nato siya himuon for our compound. So for example, propane. Propane is, prop means tatlong carbon. So you have there C3H8. This one is the empirical formula of propane, pero hindi mo na kasi siya masisimplify kasi wala silang common na factor. So this one is called the molecular formula of propane, but this can also be called as well as the empirical formula. But for 2-methyl propane, so example, you have there carbon, carbon, and carbon, tatlong carbon, and then at the center you have a methyl. So this is CH3, CH3. If this is the methyl propane, the molecular formula here is C4, and then H, 3 plus 3 plus 9, 10. So C4H10. This is the molecular formula of our 2-methyl propane. Pag molecular formula, it will really give you the exact number of atoms of each element for a given compound. So molecular formula yan siya. Pero pwede mo siyang i-simplify kasi C4 and C10, meron silang common na factor. So that is syempre 2. So like, i-divide mo siya sa 2, 4 divided by 2 is 2, and then H divided by 2 is 5. So this time, this is the simplest formula na. You cannot simplify 2 and 5 anymore. So this becomes now the empirical formula of our 2-methyl propane. So I hope naintindihan yung definition ni empirical formula at the same time yung difference nila ni molecular formula. So ulito na ako, empirical formula is the simplest formula of a given compound. It will not really show us the exact number of atoms. It will show us the number of atoms for each element though, pero it's not really the exact number of atoms. But kung gusto natin exact number of atoms talaga ng each element present in the compound, we will be using the molecular formula. Okay, so hanapin nyo lang ang factor, i-reduce nyo siya. That will now be the empirical formula. So ito, na-mention ko na siya kanina, molecular formula will really show us what element or elements are present in the compound as well as the exact number of atoms for each element. Though hindi niya ibibigay yung exact arrangement ng mga atoms, but exact yung number. Kung like si propane, it will really have 3 carbons and 8 hydrogen. Kung methyl propane, 4 talagang na carbon and then 10 na hydrogen. So yan yung kaibahan nila ni empirical formula. Pero again, it will not show us the arrangement, the correct arrangement of the atoms. Hindi natin makikita kasi kay molecular formula kung sino yung nakabind kay carbon, anong carbon ang nakabind sa another carbon na ito na meron ding nakabind na hydrogen. So hindi natin makikita ang bonding pagdating kay molecular formula. Now we also have the so-called shortened or abbreviated formula, or some will actually call this condensed formula. So parehas lang na silang tanan ha. Shortened or abbreviated or condensed formula. So sa organic chemistry, actually ito yung pinaka ginagamit when we want to present the formula of a given compound. kasi it will not really summarize the number of atoms for each element, but actually this will show us the arrangement of the atoms or the molecules. So for example, the propane, you will really show that it will really show us na meron kang carbon dyan. Unang carbon will have 3 hydrogen, another carbon at the center will have 2 hydrogen bonded to it, and the last carbon for propane will be bonded to another 3 hydrogen. So again, this will show us the sequence of the molecules. We call it shortened or abbreviated formula. So kung may makita mo CH3, CH2, CH2, CH3, and so on, ano na siya, shortened, abbreviated, or condensed formula. So pwede pwede sa ngani class, CH33CH, wherein gi-condense pag yun o pag maayo, no? Na, kasi diba you have here, gidrawing man to na ko kagaina. Sa taas na kay CH3. Then you have CH3 here. This one can also be called a condensed formula though. But kung gusto pag yun mo i-condense pag yun siya, i-abbreviate pag yun siya, since you have 3 CH3 there, butang lang nimo siya inside the parenthesis, and then butangan nimo siya subscript na 3. Kay tatlo man na sila kabuo. And then sa gawas ang CH. Okay, pwede pod na siya. Pero usahay maglibog na ta kung grabe na gyud siya ka condensed. So better use this as straight chain, or for the branch you can use this one also. Condensed formula gihapon na. Now, kung dili shortened or abbreviated formula atong gamiton, because we really want to know the exact location of the elements or the atoms in our compound, then we can use the full structure or the full na formula ng ating compound. So ito yung dinodraw class na ihiwalay talaga lahat, like hydrogen. Ipakita natin ang mga elements, lahat, the bondings, pero 2D lang ang structure. Okay, 2D lang siya. This gives us a 2D projection representation of our molecule, and it will really show us how atoms are being connected with each other. Okay, full structure ang tawag ana. Now, we also have stereochemical formula that will give us a 3D structure for our compound. So, muna inyuhang makita class sa kanang mga representation, good kanang gamitan nila og bilog. Example, this one. This example, this is water. Water lang ako example ha. This is H here, and then you have an oxygen at the center. So we have a 3D structural or spatial arrangement of the atoms pag stereochemical formula, and at the same time it will give us the representation of the size of the atoms. Kasi kung ingani magkita nato that the atom for hydrogen is smaller compared to that of the oxygen. Okay, so muna ang kalahian sa mga formulas na ginagamit nato for organic chemistry. Questions so far? Question? By the way, natin ginatawag og ball and stick formula ha. Katong I don't know kung gipahimo ni siya sa inyo ha dati. Kanabitaw ginapabuhat mo og styrofoam nga like bilog. Tapos idugtong ninyo ang stick niya. Tapos another bilog here. And then stick na naman. We call that ball and stick na formula. Okay, sige. Nakabuhat mo, ana. Ball and stick formula ang tawag, ana. That is different from the stereochemical formula. Kasi si stereochemical formula, you cannot really show the bonding na kanigyod, kani mga short in ha. Idugtong naman good na nila mga bilog-bilog. Okay? So, inganan bro, manugog ng ang drawing. Sabukay. Okay, gihimog decoration. That's a ball and stick formula. Okay. Now let's talk about isomerism. This refers to the existence of two or more compounds having the same molecular formula but different substances. Take note, the definition of isomerism, you have here two or more compounds. They have the same molecular formula, but actually they are different substances. So let me give you an example. You have here the glucose and the fructose. I believe you are very familiar with this in your biochemistry. These are two different sugars, but they have the same molecular formula. So parehas silang C6H H12O6. So parehas ilahang molecular formula, pero remember that glucose is our physiological sugar and fructose is our fruit na sugar. Isomerism ang tawag. Ana. Now, stereochemistry is the branch. So, di ba, organic chemistry is a branch of chemistry, but ang chemistry naman is further subdivided or classified into different branches. So we have here the first one, stereochemistry is dedicated to the study of isomers. Meaning, pag-aaralan natin yung mga different compounds na merong the same molecular formula. So we have here the first one, isomers. Pag narinig nyo itong term na ito, isomers refer to compounds na again, they have the same molecular formula, but what is different? They have different structural formula. So yung pagkasunod-sunod ng mga atoms, their arrangement, ang bonding, different. Pero if we summarize everything, gawin natin yung molecular formula, pareho sila. Now, isomers are due to the following. Depende yan siya. The first one is structural or constitutional, meaning there is a difference in the order of the atoms in our compound. Pero pag it is because of stereoisomerism, the difference there is on the spatial orientation of atoms or arrangement of atoms in space. Isa-isa ho nato siya para masabtan ninyo unsay difference kung isomer is due to structural or constitutional or stereoisomer. Anyway, sige, let's start first with the isomers that are formed due to difference in order. We have here structural isomers. Again, they differ in order or arrangement of the atoms or bonds. Kunya, further divided pagid ni sila into three. They can be chain isomers, position isomers, or functional isomers. Order ha or arrangement sa mga atoms. Pag sinabing chain isomers, they differ in the arrangement of carbon atoms. So this is because of the presence of the branching. So parehas ani, N-butane and isobutane. Pag nakita nyo itong N-class, it means yung ano lang, straight chain lang talaga. Butane is 4 carbons, right? So you have 4 carbons there. And then syempre may mga hydrogen. So this is CH3, CH2, CH2, and CH3. Kapag ka straight chain lang talaga siya, 4 ang carbon, we call this butane. But to be specific, let's write here N-butane. Now let's differentiate it with the isobutane. So isobutane if nasa gitna. Okay, nasa gitna siya. So you still have 4 carbons. So ganito ang arrangement niya. Yung isang carbon plus is nasa gitna. Kaya nga siya iso. Kasi if you divide this structure, you will have the same image dito sa right side. This is the right side and the left side. So lagyan natin siya ng hydrogen. 1, 2, 3. So meron siyang isang hydrogen here. and then this is CH3. So we call this isobutane. So yan yung kaibahan nila ha, arrangement ng carbon atoms, meron branching na nangyari. Parehas silang butane, branching lang ang nagkaiba. But if we look at their molecular formula, kung i-summarize na to ilahang molecular formula, this is syempre C4 and then H, 5 plus 5, C4H10. Now, if we look at isobutane, this is still C4. You have 4 carbons and then 3, 3, 3, 9, 10. So this is still C4H10. Therefore, N-butane and isobutane are really isomers. They have the same molecular formula, but they have different na structure. To be specific, they are called chain isomers. The difference is on the arrangement of the carbon atoms. Yung isa straight chain, yung isa naka-branch. Chain isomers ang tawag dyan. Okay, questions? Questions so far? Sa chain isomer? Isomers pa lang tayo ha. To be specific, structural isomers pa lang. Number 1, chain isomer. Wala yung pangutana. So let's move on. The second type of structural isomer is called position isomer. So what is the difference now? Siyempre isomer, parehas pa rin sila ng molecular formula, but the difference here is in the position of the substituent or unsaturated bonds and functional groups. So position, most of the time it's on the position of the double or triple bond, or it can be the position of the substituent. So let's take for example butene and 2-butene. But means 4 na carbon and meron kang in, ang ending niya ay in, meaning alkene siya, may presence ng double bond. So pag tinawag mo siyang butane, meaning dyan, ang double bond ay makikita sa carbon number 1. Okay? So wait lang ha. 4 pa rin ito na carbon. So lalagyan natin ng hydrogen. This is CH2, 1, 2, 3. So CH na lang, 1, 2. This is CH2. So this is the so-called butane. And pag 2-butene, ang meaning niyan, the double bond is in carbon number 2. So you have there C, this, nandito ang double bond. And then i-fill in mo siya with hydrogen. So this is CH, CH, and CH3. Now, different yan. Different sila na compound, different position of the double bond. But if you look at it, ayan, pag molecular formula na ang gagawin, pareha sila. So this is C4 and then H, 2, 3, 4, 5, 8. C4H8, while the other one is still C4 and then H8. So yes, the same pa rin yung molecular formula. Again, the difference is in the position of either the double bond or the triple bond, and as well as the position of the branches. Any functional group, basta ang difference lang nila yung position. Kagaya ng ortho, meta, and para. Kinsay makahinumdum pa din sa position aning ortho, meta, and para? Makahinumdum pa ba? Or wala na, na-erase na? Anyone? Sa manang ortho?
2, 3, 4 po, ma'am.
2, 3, 4. Sige. Let's have an example ha para makita ninyo ang kanimang good, ang first example, position sa bonding. So let's have the difference sa functional groups when it comes to the branching ha. So example, this one. Ay, kasunod na to para di mo maglibog. Okay. So this is class, take note. Pareha sila, no? Kung bilangon na to ang number of carbons, number of hydrogen, and even the number of oxygen, pareha sila. But what is different? Diba ang position? Position sa branch or sa functional groups nga naka-attach. So kapag makakita kayo ng compound na may dugtong sa pangalan na ortho, meta, and para, they actually have the same molecular formula pero iba yung position ng mga functional groups. So this one is the so-called ortho. So this is 1, 2, dihydroxy, kay duha ka buok nga hydroxyl, OH, and then benzene. So you have the benzene ring. Yeah. Okay, and this one is the meta. Meta is 1, 3. So parehas lang, 1, 3, dihydroxy, and then idugtong na to ang benzene. And lastly, this one is the ortho, or this is the 1, 4, dihydroxy benzene. Okay? So pwede nimo siya i-abbreviate as ortho dihydroxybenzene, meta dihydroxybenzene. Sorry. para. Okay. Para dihydroxybenzene. Okay? Sige. I hope that is clear. Pag position isomers, ang position either sa double bond or sa imuhang functional group nga i-attach. And lastly, for our structural isomers, we have here the functional isomers. They have, again, the same molecular formula, but the difference here is in the functional group. So for example, ethanol and dimethyl ether. Remember, different ilang functional group. Syempre, ethanol is an alcohol, while dimethyl ether is an ether. Different ang functional groups, but for their molecular formula, ethanol, remember, is CH3, CH2OH. So, naa ka din hay duha ka carbon, and then hydrogen, 3, 6, yeah. And then you have the oxygen. So this is the molecular formula for dimethyl ether. Remember, pag ether, si oxygen na sa gitna, dimethyl meaning dalawang methyl sa sides. Okay? So if we get the molecular formula of this, you have C2H6 and still 1 oxygen. So as you can see, they have the same molecular formula, pero they have different functional groups. We call them functional isomers. So I hope nasabtan na siya na definition sa mga different types of isomers nato. Silang tatlo, chain, position, and functional isomers are under structural isomers. Okay. Questions? Wala? Structural isomers na sila, ha? So, humanata sa first type sa isomers. The second type is stereoisomers. So, unsa pud mi sila? Stereoisomers, they are atoms that have the same order but different ang orientation in space nila. Meaning yung pag-arrange ng atoms in space, dili pareho. Pero pag waon gihapon nato ilahang molecular formula, same sila. So we have types of stereoisomers. We have the geometric isomers, optical isomers. Examples of optical isomers, we have the enantiomer, diastereomer, epimer, and anomers. And lastly, we have the conformational isomers, or we also call this as conformers. Okay, wait lang, ha? Oh, wait. Sige. So let's talk about geometric isomers para ma-picture out ninyo unsay nahitabo sa stereoisomers and how are these different from the structural isomers na human na nato og discuss. So for geometric isomers class, this can occur if a compound contains a double bond. Again, mahitabo lang ang geometric isomer pag naatay double bond or if cyclic siya. So mao ni siya class ang katuganing na ay cis and trans or E and Z. I-draw na siya. So for example, 2-butene. Either double bond or cyclic siya ha. So 2-butene meaning na we have here double bond at carbon number 2 and then wait lang. Orientation in space manggod ni siya. So naamang good ni siya carbon here na CH3 while na pa siya isa ka hydrogen. 1 2 3 yan na siya isa ka hydrogen. Okay. Sige. So this is what you call the cis 2-butene. Ganong cis man. For example, hation nato ang atoang compound. So parehas sila class. Parehas tanan CH3 nasa taas, parehas hydrogen nasa baba. Cis ang tawag ana. Pero kung trans, let me draw it again. 2-butene gihapon ha kasi nasa carbon number 2 ang double bond. Pero dili sila pareho. This one. So this is what you call the trans 2-butene. If we divide the compound into two, the upper part will have the CH3 and BH, while on the other sa baba hindi sila magkapareho. Unlike this one is the cis and this is the trans. So geometric isomer siya. Pag tanaw nato ang ilahang molecular formula, parehas lang man. Parehas lang ilahang molecular formula. This is C4H8. Ito, C4H8 gihapon. Pero unsay difference ang ilahang orientation in space. So cis and trans. Any questions so far with the cis and the trans? Pag same side, ang inyong tandaan, same side is cis. And pag hindi magkapareho ang side, we call that trans. Wala? Sure na? So other term that we can use for cis, actually we can call this as Z. Cis is for Z and trans is for E. So whether you call that cis 2-butene or Z 2-butene, or pwede po trans 2-butene, and then you can substitute the trans for E. E2-butene. Okay, mo na ang ilahang kalahian. Cis and Z, same side. Trans or E, different sides sa geometric orientation. Okay? Ako siyang drawing. Tapos naday ko yung example din. Pagkalimot ko. Okay? So, another class na meaning sa E and Z is this one. We have the priority groups on opposite sides. Ang tawag na to ana kay E configuration, but if the priority groups is on the same side, we call that Z configuration. So wait lang. I think I have a copy of this sa, how do you know the priority? Let me check. Isulat na ko ha. Isulat. Balhin siya ako sa ilalim. Saan ba ito gibutan? Okay, so kagaina sa cis and trans manggod, parehas manggod to sila no, na CH3 and hydrogen. But if you look at here, ano sila? Apat sila na different atoms. So like fluorine, iodine, chlorine, bromine. Apat na sila. So we cannot really use the cis and trans here. Dili na to pwede gamiton si cis and trans kay kung ato silang i-divide, dili ta maka-decide. Kay lahi-lahi man sila, fluorine, iodine, chlorine, and bromine. So that's the time, mo ni siya ang kanang pinakatama gyud nga definition ni E and ni Z. Pero wait lang ha. Because I think wala na ko siya gisali. Yeah, wala na ko siya gisali ang priority group. Na atato sa ako ang nakapagibutang. Wait. Wait lang. Okay. Sige, this is based So kung hation nato ni siya class, yun sa nila paghati. That's one. Nga ni paghati ha. Based man gud sa pagsulat sa compound. Sulat na lang nako. Pag E, di ba ingon ko mura siya trans na different side of priority. Ay, sulat tayo sa ilalim. Anyway, how do you know the priority? It's on there. Ani na lang ang simplest para mas dali siya. Atomic number. The larger the atomic number, the higher the priority. For example, kani, ingani siya pagkahati ha. What is the atomic, you have the periodic table. Let me open periodic table ha. Para exact ang atuang isulat na atomic number. Periodic table. I don't memorize the atomic number. F is pagamay. So F is 9. That's the atomic number of F. And chlorine is 17. Iodine is 53. And what's the other one? Bromine is 35. So kung nakita ninyo nakabilog ang priority, nga naman, kung hation nato siya ingani pinainganig hati ha. Syempre, since chlorine has the higher atomic number, it will be given much priority. Now, between the two, iodine and bromine, syempre this one is 53, so siya ang priority. Now, since they are opposite side, ang isa nasa taas, ang isa nasa baba, that is why we call this an E configuration. So again, gamiton nato si E and Z configuration if we have 4 different na functional groups ha. And then, or kung dili siya functional groups, 4 different atoms. So kanipod, so parehas lang man ang ato ang atomic number ani, 9, 17, and then bromine is 35, and then iodine is 53. So kani, the priority is both on the same side. Bisag anaan pa nato siya og hati na silang duha sa baba. So mo na siya nga Z configuration. So Z same side para dali ninyo siya matandaan. Z same side, or appeal na to si cis dinhi. And then, ang opposite nila, si trans, kung parehas sila functional groups, pero kung different, we use the E. So, I hope that is clear. Questions so far? Walay? Walay na? Sure na gyud? So, pansiranutan ako sa inyo ha, pero kay ibutangan naman dahil niya Z-form o E-form. Anyway, sige ka na, lahi-lahi ba na fluorine man to kagayin na, no? So, bisag hation na to siya og pinaingani. So, syempre, among the two, this is 17 and this is 35. 35, and then iodine is 53. And then, tama ba? Akong gibutang, paka lang ko. Iodine is 53, yes. And then, hydrogen is 1. So, kung tanawon nato class, this one is the same side. Kasi the priority, parehas silang nasa taas. Okay? Parehas silang nasa taas. Well, in this E form, this is 3517. Pero take note, iodine is parehas naman ni. Nabali lang siguro ni ClH. Balik taron na to class. Kaya nga naman na siyang parehas sila. Okay. If this is the case, for example, this is H here, this is 1, and this is 53. This one is the E form kasi pag atuan na siyang hation, the priorities are on the opposite side. But take note, since these are isomers, they have the same molecular formula, but ang orientation nila ang dili pareho. So, unsa gani tawag ani? Geometric isomers. Okay? Next. We're done with the geometric isomers. Pag geometric isomers, upat lang na sila ha, cis, trans, and E and Z. And then, optical isomers. We have 4 types of optical isomers: enantiomers, diastereomer, epimer, and anomers. So let's start with the enantiomers. Optical ha, optical. So pag ang meaning ng enantiomers, they are non-superimposable mirror images. They might have the same physico-chemical properties, pero again, ang hindi nila magkapareho dito is yung optical kasi pag tanawon nimo sila, murag parehas sila og image, parehas sila molecular formula, pero pag imuha na sila i-impose, dili na sila imposable. So parehas ani D and L glyceraldehyde. Ay, na-answer na ko ni imuhang question, Jessa, before ko mag-move on. Paano malaman ang priority sa atomic number? ang mas dako og atomic number, mas taas iyahang priority. That's how you know the E and the Z. Okay? Sige, let's go back to the enantiomers. Again, ang meaning, pinaka-meaning yun sa enantiomers, non-superimposable mirror images. Pwede sila nga magkapareho og physico-chemical properties. So again, we have here D and L, glyceraldehyde. So if you look at this, they are actually mirror images of each other. Kung atuwa silang iatubang sa mirror class, magkapareho sila. Pero kung imuha na siyang i-impose, dili day sila magkapareho. Nasabtan to? Like if we take this and then isulat nato siya dire, ayan. The other one is H, the other one is OH here. Ayan. See, oh, wait, let me delete this. Ayan, dili di ay sila imposable. Kaya kanang naa sa tunga, OH and H, baliktad ay ilahang position. Pero mirror image sila. Meaning pag ibutang nimo sila sa mirror, parehas sila. Pag iatubang nimo na sila class, parehas sila. Dili lang sila imposable. Ang tawag nato ana enantiomer. Pero parehas man sila nga glyceraldehyde. Therefore, ano sila? Optical isomer or enantiomer. Parehas sila physical and chemical properties. Okay. So, syempre, kay isomer man parehas sila og molecular formula. Okay. Kamay. Pag imuha na silang iatubang, parehas sila. Ana ang enantiomer. So, parehas nagatubang ang imuhang thumb ug ang imuhang other fingers. Pero, kung imuha silang i-impose ang enantiomer, dili dai sila pareho. Okay? Sige. Any question? By the way, what's the meaning? Since nag-message man, kita itong nag-message. Let me look at it again. As is si Jonabel. Chiral. How do you define chiral carbon or ang property ni na chirality? What's the meaning ani? Anyone who can still remember the meaning of
Ano ma'am?
carbon?
Katong carbon na bonded sa 4 different na groups ma'am.
Okay, very good. Tama. This one here, the carbon here at the center actually exhibits chirality, or it can be called chiral carbon because ang apat na bonding niya 4 different elements, 4 different atoms or functional group. Ito si HOOH, si H2OH, and this one is hydrogen. That's what you call chirality or chiral carbon. Okay. So, kani sila, this is what you call enantiomer. Now, how about diastereomer? Unsay kalahian ana niya kay enantiomer. So, si diastereomer is with at least 2 chiral centers. They are not mirror images ha. Dili sila mirror images parehas sa D and L na glyceraldehyde kagay na nga pag iatubang nimo sila pareho sila. So, dili sila mirror images, therefore dili pud sila superimposable, and take note, different ilang physico-chemical properties. So this is a total different one compared to that of the enantiomer. So let's have an example for the diastereomer. We have here the D-glucose and the D-altrose. Una, pag iatubang nimo na sila class, hindi sila magkapareho. So they are not mirror images of each other. And at the same time, dili po sila imposable, superimposable. Pag kanikwaon nimo, itapal nimo siya diri, butang nimo siya sa taas ani, dili po sila magkapareho. Unsa lang ang ilahang pareho, they have at least 2 chiral centers. So meaning ana naa sila'y at least duha ka carbon nga naga-exhibit og chirality. So, unsa kaya na? Una siya ang naka-blue. Wait lang ha. Kaya busy kayo ang GC sa inyong mga maestra. Okay, CHO. Wait lang. Ay. So, kani, glucose and maltose are two different sugar. So, syempre, kay different man sila na sugar, they have different physical and chemical properties. But take note of this, parehas sila neto, CHO. Ito, dili ni sila pareho, baliktad sila. This one, pareho sila. And then this one, pareho sila. So we have here, kanilang, at least two, na actually chiral, and hindi sila magkapareho, the rest pareho na. So yun lang ang kaibahan ng diastereomer and ni enantiomer. Because of these two chiral centers here, hindi na sila mirror image and hindi na din sila superimposable. Pero the rest of the structure, magkapareho sila. That is diastereomer. Okay? And then pag epimer, ay, samo kayo. Samo kayo. Sige. Epimers. Sorry kay class kay. Actually, busy ang GC. Kay wala pa mong good na finalize ang uban ng mga schedules. So, nagkalibog-libog kami kagaina sa chem, sa medtech. Pero ang pharma, na-plot na. Wala na tayo changes sa pharma na schedule. Na medtech na lang mo nang sige akong cellphone distract ko. Kaya siyang italikod. Okay, italikod na to. Next, epimers. Epimers are actually special type of diastereomers. Unsa lang? They are identical in all except one chiral center. Again, parehas sila tanan except isa. So, mo na siyang gitawag siya special type of diastereomer. Kay kagaina sa diastereomer, di ba? Parehas na sila sa uban, nalang kay at least two chiral centers nga parehas sila. Kani isa na lang yun ang dili sila magkapareho. The rest, identical na. So, they differ in only one carbon except for the carbonyl carbon actually. Kanang carbon nga nakabind sa oxygen. So, let's have an example, the D-glucose and the D-galactose, and then we'll have the mannose and the glucose. Dapat na to silang tanan. D-mannose and the D-glucose. So let's check. Kanisang duha. They are epimers at carbon number 2. Carbon number 1, yes, parehas sila. Carbon number 2, this one, hindi sila magkapareho. Carbon number 3, yes, everything, including the arrangement. The same thing with 4, 5, and 6. So therefore, D-mannose and D-glucose are epimers. Parehas sila tanan except for carbon number 2. Epimer ang tawag ana ha. Same ni ilahang molecular formula.
No, why man?
Si why man? Si Jai. Ano yun? Ansad na. Naring Jai na. Naring siya kay istorya ba? Oh, carbon number 2, epimers. Now, let's look at D-glucose and D-galactose. Yarisa. Ito po, let's mute basig mo palit na nagsagit si Jai karon. Okay. Ay, si Jai to, si Jai kay ni saka man iyahang ano diri ko. Okay, let's move on. Another example. Wala gagana ang audio. Wala gagana imong audio pero mabatian ka na mo. Okay. Sige, gora lang din ha. Okay, next. This one is a board exam question, by the way. Ganun kayo sila ani mag-question sa board exam. Unsang carbon daw epimer si D-mannose and si D-glucose. Take note, it's on carbon number 2. Diha lang sila different. Now, si diri po, board exam question pa ni siya, asa different or asa epimer si D-glucose and si D-galactose. So, take note. This one, pareha sila. This one also. Carbon number 3 also. Ito, carbon number 4 sila, hindi the same. So, they are epimers at carbon number 4. Pareha sila tanan except one carbon. Si diastereomer, at least naa sila'y duha ka carbon nga magkapareha. Na sila'y 2 chiral centers. Okay? Pero parehas ni sila class na dili mirror image and they are also not superimposable. Okay? And then lastly, I think this is the last one for optical isomer before we'll take a break again. So differ only in carbonyl carbon or anomeric carbon. So mao ni siya ang katong na ay alpha and beta sa ilahang pangalan. Most of the anomers is they are different at carbon number 1. So, ang inyong tandaan, pag naganin ay nakabutang alpha, ang natong illustration para dali siya masabtan. Like this one. Actually, mas dali makita si anomer kapag ka naka-cycle, naka-ring ang atuang structure. Ayan. Sige. So, pangitaon ninyo tong lahi sila kay the rest parehas naman na sila no oxygen and then carbon number 2 parehas sila 3, 4 and 5. Sige. So, take note, carbon number 1 dili sila magkapareho. Unsay dili pareho ana nila? Ang ilahang OH ug ang ilahang H. Ang alpha class, ang iyahang OH naa sa baba. Mabitaw alpha is down. And ako, actually personally, itong ako ang nag-take og board exam, akong gina-remember lang ani, pag mag-drawing manggugkog alpha, pababa akong drawing like this one. So, di ba pababa si alpha para makahinumdum ko nga alpha is down. And then, di ba pag magsulat ta og beta, pasaka man ta, magsulat ta og beta. I don't know about you, but this is how I write the beta. Pasaka ko. I'll start sa baba pataas. Okay? So, mo na siya ma-remember na ko si beta as up. Meaning na ang iyahang OH or any other functional group except for hydrogen na asa taas. So, the rest magkaparehas na sila except for carbon number 1. So, mas dali ni siya makita class kung naka-cycle siya kaysa sa naka-Fisher projection siya. Kasi this one, you cannot really see if it's down or up. Pero para na lang for the sake, if ever mag-Fisher projection sila, alpha if the functional group is on the right, and then beta if the functional group is on the left. Okay. Sige. So that's it for the optical isomer. This one is another example though. So like this one, D-glucopyranose. Now, this one is alpha since the OH is placed sa baba, and then beta D-glucopyranose since the OH is nasa taas. Actually, mga glucose ni sila. This one is the glucose here, the Fisher projection. Ang tawag na to ani, kapag ingani siya gisulat, we call this Fisher projection. Pero ito, naka-ring. So, pag naka-ring siya, we call it alpha D-glucopyranose. Sa baba ang OH, so alpha. Kani sa taas ang OH, so beta. So, kapag kakana lang ang difference nila class, carbon number 1, position lang kung up or down ba, ang tawag ana, anomer. So, silang tanan, under na siya sa optical isomers. So, balikan na to. Ay, asa dapat ko magbalik? Dire. Sige. Balik ta, optical isomers. So we have 4 types: enantiomers, diastereomer, epimer, ug anomers. Sa ganito, enantiomers, non-superimposable pero mirror image. So parehas lang na sila nga species. So naalay position nga nagkaiba. So pero parehas sila og physical and chemical properties. Pag dili na sila class superimposable, dili pud sila mirror image, pero parehas sila molecular formula, we call it diastereomer. Okay? Again, the same molecular formula, pero dili superimposable, dili mirror image, pero at least they have two chiral centers, diastereomer. Pag epimer, parehas sila tanan except sa isa ka carbon. So we have to locate asa sila dili pareho. So just like D-mannose and D-glucose, dili sila pareho at carbon number 2. That's the Haworth projection, kanang ring belly, that's what we call the Haworth projection. And then the D-glucose and the D-galactose, the same sila lahat, positions on everything, spatial arrangement, except for carbon number 4. So isa lang. Tawag na to ana, epimer. Pag pareha sila tanan tapos ang difference lang kay carbon number 1, ang anomer specific ni siya sa carbon number 1, up and down na position, alpha or beta, again we call that anomer. So again, how we call itong nasa gitna, that's what we call the Fisher projection. We use this structural formula or kanang representation of the compound mostly for the sugars. So Fisher projection itong nakaring mo na siyang ginatawag og Haworth projection. Okay, so let's take a break first, and then when we go back, we'll talk about conformational isomer, and dinha na to istoryahan katong mga nagring na pero napadyoy lahi pa nga way na pagkasulat sa ilaha. So oras na 5:09. So you go back here at 5:19. So lastly, this is the last one. Humanata sa optical isomers. We are still under stereoisomers. That's nasubraan. Okay, conformational isomers. So take note of this. This involves single bonds only. And sa conformational isomers, this is for the cyclic nga ring. And parehas sila cycle tanan, parehas sila molecular formula. So definitely parehas sila kung 6 kabuok ang carbon atoms, parehas sila tanan. Except that yung conformation ang different. So just like this, actually this is for the glucose. Example, this is the glucose, 6 na tanan kabuok. Actually, glucopyranose to be exact, since naging ring naman na siya. Kung titingnan natin ang molecular formula nila, parehas sila. Kaya lang, take note, parehas sila ring pero lahi-lahi silang shape. That's what you call conformational isomer. So we have here the Haworth projection, the normal ring that we have. For example, like kung 6 kabuok, like hexagonal siya, it's the Haworth projection. Pero we also have the chair conformation. The same ni sila tanan na compound, conformation man gyud ang lahi. We have the chair conformation, 6 gihapon, no, 6 ka sides, pero syempre gitawag siya chair conformation because it looks like a chair. And this one, 6 pa rin, 1 2 3 4 5 6, pero it looks like a boat, so we call this boat conformation. So again, they have the same molecular formula, but they have different shape in terms sa kanilang conformation. So this one is a board exam question, like which of the following conformation is the most stable? So the answer there is the chair conformation. When you say most stable, hindi siya basta-bastang nasisira ang kanyang structure. So chair conformation ang pinaka-stable among the 3 conformational isomers for our glucopyranose. Okay? So that's the last one for our stereoisomers. Under sila lahat sa isomers ha. Lahat ng diniscuss ko. Inyuha lang yung tandaan, they have the same molecular formula, but they have different structures. So mostly sa structures, arrangement ng mga atoms. Now in pharmacy, let us apply organic chemistry to the pharmaceutical world. We have the so-called racemic mixtures. Pag sinabing racemic mixtures, ang tandaan ninyo, they are not optically active. Again, they are not optically active. Therefore, if we test the racemic mixtures ano nga yung sa farm ninyo? So ganina, nang ginagamit ninyo to test the optical activity of the substance. So kalimot hinoon ko. I'm not really fond of the physical pharmacy. Wait, let us ask Mama Be. Charot. Kasi tawag who can remember that certain laboratory machine na to sa school? Lagi nagkamit ako siya matandaan. Okay, dugay na miwa nagkita. Wala yung makahinong daw. Lagi leso ni Mama Be sa inyo, ha? No, not the refractometer. What's the other one? Kalimot kasi ang pangalan noon. We have polarimeter. Ano po na siya, understandable na you cannot really, wala gay ko kahinumdum, no? Nya kamusad na wala mo na face-to-face laboratory sa physical pharmacy. We have a polarimeter sa school. Ginagamit siya sa farm again kasi this machine is used to measure optical activity. When you say optical activity, it's the ability of the substance to rotate plane polarized light. So mauna siya mag-identify whether your substance is levorotatory or dextrorotatory. Siyempre, pag dextrorotatory ang imuhang substance, it has the ability to rotate the light sa polarimeter to the right. Okay? Or clockwise. But if your substance is able to rotate the light to the left or counterclockwise, mo na itong ginatawag og levorotatory. So again, the machine that we used in the laboratory to identify the optical activity is the polarimeter. Now, mo na natin ginatawag og dextro or levo kana optical activity na ang ginamin ana, especially sa mga sugars, daghan tag dextro and levo, no? And daghan pud ta og mga pharmaceutical products, mga tambal, medicines or drugs na the same sila nga drug but some are dextro and others are levo. So naana siya implication when it comes to their physical properties man good. So muna siya na nabilong siya sa physical pharmacy. Now, if two substances are being mixed together, ang isa dextro and then ang isa levo, they will cancel out the activity of each other. So, pag imuha silang i-mix, mahimo silang non-optically active and that the mixture will be called now racemic mixture. So, most of the time, the concentration will be equal, 50% dextro, 50% levo. So, to give you an example, you have here the thalidomide. It's a mixture, actually 50% na levo and 50% na dextro. It will become non-optically active, racemic mixture siya. Pero you cannot actually see thalidomide nowadays kasi it's already withdrawn from the market. Dati ginagamit siya as sedative hypnotic just like our barbiturates and yung mga diazepam nato, mga benzodiazepines nato. Pareha sila gamit ni thalidomide dati pero karon na out na siya sa market. because it can cause phocomelia. So pag sinabing phocomelia class, it refers to the absence of limb. Wala man siya actually problem if the woman is not pregnant. It can actually be used as sedative hypnotic. But our problem if matimingan na the woman naghatagan og thalidomide is pregnant, pag gawa sa iyahang anak, there will really be absence of the limb. Pwede kamot, pwede tiil. Ang tawag na to ana again, phocomelia. Okay, phocomelia ang tawag sa condition. So, ano siya ang ginakos ni thalidomide, and that is the reason why it is now withdrawn from the market. Pag sinabing teratogenic, thalidomide is teratogenic class, it means there is limb deformities. By the way, amelia, pag amelia gani ang nakabutang A means no. So maugid na siya ang kanang totally, walay kamot, walay tiil. Pero pag phocomelia na ay absence, pwede isa ka kamot, isa ka tiil, or naalay mga deformities. Okay? Ang drugs nga nagakos ana is called teratogenic. So that is different from the term na carcinogenic because carcinogenic substances ang ginakos ana nila ay neoplasm or cancer. So I hope na sabtan na siya. Kasi ma-encounter ninyo siya sibuon with your review or even sa board exam basig magawas siya. Now, let's discuss. Actually, this is not really included sa organic chemistry, pero for the sake na i-relate nato si organic chemistry with the pharmaceutical world, let us talk about the pregnancy categories that you will see in the labels of our pharmaceutical products. Okay? So, naka A, B, C, D, and X na siya. Pag mag-dispense gani mo o medication, you can look at the label again and see whether the medication is permitted to be used sa mga pregnant or hindi. So pag nakalagay dyan, pregnancy category is A, we have studies sa animals na apuntay studies sa human ana. And they have found out in both studies that the medication is safe for pregnant women. So okay lang siya i-prescribe sa buntis. That is, we have the example here, paracetamol. For example, ang pregnant na babae nagkaroon og lagnat and hatagan na to siya paracetamol, okay lang, safe siya. Safe kasi both animal and human studies nag-ingon nga safe siya. But pag ang nakalagay sa label is pregnancy category B ang ato ang tambal, sa animal pwedeng safe, pero pag abot sa human studies pwedeng hindi na siya totally safe. But nevertheless, permitted pa rin siya to be used in pregnant women, pero with caution and constant monitoring sa OB/GYN. So example ng pregnancy category B na medication is the amoxicillin. Okay? Example, if the patient has like infection and then kailangan talaga bigyan ng antibiotic, we can give amoxicillin. Now, pag pregnancy category C, you have there still animal study, and yes, it is safe according to the results of the animal studies. But for human studies, pwedeng walang human studies or pwedeng meron, pero hindi talaga siya safe according sa results. Itong C, parehas man sila ng B and C, no? Parehas sila ng letter B na category, pero ito, the results are mostly unsafe talaga, especially sa human. So, hindi talaga siya dapat ibigay sa pregnant, pero may mga exceptions lang yan siya. Kung kailangan na talaga, so pwede na lang. Pero kung strict lang talaga pag pregnancy category C na, unsafe na dyan. So example, we have here the theophylline. The theophylline that we used, for example, sa asthmatic people. Pero kung meron man tayong pwedeng i-substitute sa theophylline for that condition, kato na lang kung safe siya sa buntis. Now, pag category D na jud na siya, we have the human study and at the same time, animal study. Available lahat ng data, pero all the studies nag-ingon na unsafe gyud siya. Category D na, pero take note, unsafe but pag ma-outweigh ng benefit niya yung risk, that's the only and the only time you give this medication to pregnant women. So like phenytoin and tetracycline. Dili, as much as possible, dili na lang yun ihatag. Pero kung as in wala na yun lain and that kanang ma-outweigh na yun niya tanang risk, kana pwede siya ihatag. Pero pag X na yun na siya, meaning ana, complete ang studies ha, both animals and human, mo nang nakabutang din ha nga yes, pero both studies or tanan klaseng studies din ha nag-ingon na dili jud siya safe kay teratogenic siya, automatic mag-X na iyahang pregnancy category. So na-include din ha si thalidomide mo na nga wala na gid siya ginagamit karon kay it can cause deformities sa limbs. Okay? As well as warfarin and even vitamin A. Vitamin A is actually category X. We really need vitamin A no sa body, pero kanang deliberately ihatag nimo ang vitamin A sa pregnant na babae, makaapekto siya sa infant. So that is the reason why I don't know if you are familiar with the drug isotretinoin. Ayan, ginagamit na siya for acne. Again, ginagamit niya siya for acne. This is a derivative of vitamin A class. Ano siya? Dili siya pwede ihatag for buntis kay teratogenic siya. Isang pag-i-ana lang mo na siya sa imuhang nawong, since it can also be absorbed in the body even via the skin and it can affect the infant sa sulod. Dili jud siya pwede ihatag. Pero isotretinoin is actually available in the market nowadays. You just have to make sure na ang pag mag-dispense ka ani kung pharmacist na mo puhon, you really have to make sure na hindi buntis ang gagamit ng drug na yan. The isotretinoin. Okay? Questions so far? Naglubad na akong tingin. Suda mag-lesson ng 3 ka oras straight. Wala pangutana. Sure na yun. Okay, sige, let us continue. So this is still the application of organic chemistry to the pharmaceutical world. So naata ginatawag og biosusteer. These are actually substituents or groups or functional groups na they have physical and chemical properties, and pag bisag i-interchange nimo siya, for example, ang original drug contains this certain functional group. Now, itong certain functional group, meron siyang parang, how do you call that? Parang pwede mo siyang i-substitute. Okay? Pwede mo siyang i-substitute na another functional group. Bakit pwede yung substitution? Kasi most likely they have similar physical or chemical properties. So kung ito yung original drug, gagawa ka ngayon ng another drug with a functional group na substitution, but most likely they will have the same mechanism of action or effect in the body. Naalang siya yung mga, syempre na-add siya yung difference, pero the difference can be beneficial sa imuhang second drug nga himuon. Okay? So what's the purpose of doing biosusteer na we will make new drug and then we will substitute this specific functional group with another functional group. So the first one, enhance the desired biological or physical properties of a compound without making significant changes in the chemical structure. So we only do substitution of another functional group if it is beneficial because it can enhance the effect of the drug, or it can increase the potency, meaning it will be more effective. It will be effective even if at lower dose mo siya ibibigay. And it might be because the substitution of this certain functional group can decrease the side effect of that drug. Biosostere ang tawag na to, ana ha? And then it can be due to the increased duration of action by altering the metabolism of the drug. So instead of, for example, ito yung specific functional group, OH originally siya. Tapos gusto mo the same mechanism of action, the same effect, pero gusto mo lang talaga i-prolong ang duration of action, then you can use another functional group for that. I-substitute mo siya doon sa structure ng drug. So yes, pharmacists and even chemists do that. That's a collaboration between the two kasi yung pharmacist, syempre we are more knowledgeable when it comes to the activity of the drug in the body, and then the chemists are more knowledgeable when it comes to this functional group. So ano na siya, collaboration na pirmi. And then isosteric analogs may act antagonistically with the parent molecule. So depende kung ano talaga ang purpose, bakit mo papalitan ang functional group with another functional group. Pwede to enhance the activity, or you may have to make another drug that will become an antagonist. Example, kung sa toxicology pa na world, makadevelop ka og antidote for the poisoning of that certain drug. So what are the examples of biososteric replacement? Example, the original atom or functional group in the original drug is fluorine. You can actually substitute it with a hydrogen. So it can make the drug lesser ang side effect or less toxic. Okay, pwede na siya himuon. Or you have here the hydroxyl. You can substitute it with an amino acid and vice versa depending on the purpose ha. And then hydroxyl versus the thiol groups. And then we have here the methyl, methoxyl, hydroxyl, and amino groups can also be substituted with hydrogen, and then again vice versa. And then fluoro-chloro-bromo-thiol, kani sila can be substituted by a methyl and other small alkyl groups. That's how we make new drugs in the market. And the new drugs can have different purpose, the same mechanism of action. Mostly ang different nila is on the dose, for example, the duration of action, or to summarize, it's on the pharmacokinetic profile of the drug. Again, we call that biosostere, functional groups that have similar activity. Okay? Any question? It's 5:48. Ba may gusto ipangutana so far? Wala pa gyud nag-isa-isa sa mga functional groups ha. Gitapok lang nako ning organic chemistry, i-apply na to siya sa pharma. Wala pangutana. By the way, maanad mo sa review ha, kay sa review, for example, ato ang PICOL, duha ka SEM. So that's a total of 1 year. Pero sa review, you will just have the pharmacology for minimum mga 5 days. So mo na paspasanay siya, you really have to catch up. Wala pangutana. So let us continue with the types of organic reactions. Types of organic reactions. It's not really similar with the inorg, because sa inorg, diba, you have the synthesis, what's the kabaliktaran ng synthesis? The decomposition reaction, single displacement o double displacement. This time, iba yung mga organic reactions natin ha. The first one is called addition, wherein you just have to add the atoms to the organic compound nimo. For example, we have here an ethene. Ethene because you have 2 carbons and then you have the double bond connecting the 2 carbons. And then if you will have, you will add the hydrobromic acid here. So, i-distribute mo lang siya actually, class. Sa addition, the hydrogen can be given, for example, to 1 carbon, and then the bromine will be given to another carbon. Okay? Or since parehas kasi silang CH2, so any of the carbon na lang. So in this case, na-distribute na yung bawat member ng inad mo na compound. So the first carbon will be CH3 and then the other one will carry the bromine. That's how addition works. Okay, again, that's how addition works, class. I-distribute natin yung mga components ng ating compound to the organic compounds. Yung inad natin na compound ang i-distribute. Any question, class? Wala? So, paano kung, for example, ganito siya? One, two, three. Okay. And for example, atong i-add kay HCl. Ano na to ni siya i-add? Asa na to dapit i-distribute? Okay lang kasi yung first na example kay duho lang man to ka carbon. Paano kung more than that? Anyone? How are we going to distribute this one? Take note sa addition ha. The hydrogen will be given to the carbon with more number. Yung carbon na nabilong sa double bond ha, hindi kasali itong isa. Kaya wala man na siya na-involve sa double bond. So the hydrogen will be connected to the carbon with more number of hydrogen, while yung kasama ni hydrogen, pwede siyang halogen, for example, kay kanina bromine, ngayon chlorine, this will be attached to the carbon with lesser number of hydrogen. So if we distribute this, kanilang atong tanawon ha sa kaning carbons involved in the double bond, hydrogen will be given to the lesser one. So this, sorry, more. Mali ang ako ang ibutang nga arrow. Nan, wala nang antipara. Kapoy ko antipara, sakit ang ilong. Nabugatan. Okay, hydrogen will be some more number. This one, so diri siya. And then the chlorine will be given to the lesser number. So this will become now CH3. So instead of CH, mahimo na siya CH2. And then, sorry, baliktad. Unsa kong gibutang lesser. Dalagot may mag-antipara na lang ko ba? CH3. And then, again, sa lesser, so this is still CH, and you will have to place the Cl here. And then the hydrogen will be to the more number. So ito, CH2 man siya, magiging CH3 na siya. So this will be now your reaction. Okay, CH3CH double bond CH2 plus HCl will give you CH3CH, Cl, and CH3. So I hope that is clear. Klaro na ba? Or we will continue. It's 5:54 naman there. Sige. So dinha lang sa, I will have more examples of the addition na chemical reaction next meeting. And then we will discuss the other types of organic reaction. So for the quiz, hindi ko muna isali, naka-record yun na ha, hindi ko muna isali itong types of organic reactions kaya hindi ko siya natapos. So hanggang here, sa biososphere ang atuang quiz next meeting. And then we will have another set of quiz for the part 1 of the Gen Chem.